Hey everybody, wanted to make a video covering all the parent functions that you'll see in Algebra 2, and in this video I'm going to talk to you about the domain and range of each function because that always comes back each section that you kind of expand on that type of function, especially when you talk about transformations. You're going to talk about how that transforms the domain and range of everything. And in this, I'm going to go over the domain in inequality form and interval form, okay? So to start off, this is a linear function. It makes a line, okay? The parent function of that would be y equals x. If you notice in all these, I use function notation, which just means I'm writing f of x. It's the same thing as y equals, but f of x, I guess, looks fancier. I don't know. I think it's more mathematically correct. That being said, looking at the domain and the range, domain's going to move on the x-axis. Okay, so move from side to side. Is it restricted at all? No. It can go left and right forever. Same thing for the range, up and down forever. So negative infinity to positive infinity, as an inequality form looks like that, interval form looks like that with parentheses. And then I just made a note here. Anytime it's all real numbers, that means there's no restrictions at all. You can plug in any number. You'll say all real numbers a lot of times. And so it's not technically inequality form or interval form, but it is a symbol worth knowing, and so I thought I'd just bring it up in this video, so that way, maybe in the future, if I just ask you what's the domain of this function, and I don't say write it in inequality or interval notation, you can just say all real numbers. But yeah, let's move on. This one is absolute value. If you want to remember this, it's a v, absolute value, v for value. Now, the domain moves left to right, and it's unrestricted. So, all real numbers for the domain. But the range, it is only in the positive values, and it does touch 0. I understand that it's kind of hard to tell if it looks like it hits 0 if you're looking at the graph. But trust me, if it couldn't hit 0, you'd see like a clear curve. I know this curves, but it curves through 0. So I'll point it out when we get there. It's on the next page. But this does touch 0, so y is greater than or equal to 0. So it covers all the positive numbers and 0. And then in interval notation, put 0 in a bracket. Okay, the absolute value function is also, it's important to note that you say f of x equals, and then you put x in these bars, okay? For someone who's never seen an absolute value function, it looks like x is it looks like it says 1x1. They're not ones, they're just bars. Bars symbolize absolute value. The reason why you can only get positive numbers is because absolute value always outputs a positive number. So think of it like this. In terms of distance, if I walk forwards 10 feet, I've traveled 10 feet. If I walk backwards 10 feet, you might think, oh, I'm traveling in a negative direction since I'm walking backwards, but I still only traveled 10 feet. I can't travel negative 10 feet. So things like distance are always absolute value type measurements. And so that's kind of a practical application of it. Moving on to the quadratic function, that gets you the parabolic graph, you'll see that it's not restricted at all in the domain. It can go left or right forever. But same thing as absolute value, only on the positives, but it can't be 0. That's because you can square 0, and then if you square any number, positive or negative, you're going to output a positive number because a negative times a negative equals a positive. Now, I did call this a polynomial even function, and I added this note, or f of x equals x to the power of n, where n is even. That's because if you plug in like x to the 4th, or x to the 6th, or x to the 8th, you still get a parabolic looking graph. All right, this graph right here is specifically x squared, but so that's why I put it on here, because you deal with quadratic functions quite often in Algebra 2. But you do deal with polynomial even functions. You can't call them quadratic unless it's x squared in Algebra 2 as well. So it's worth adding on there. So you'll see on the next one, I call it the cubic function or polynomial odd. And again, that would just, if you're plugging in like the third power, fifth power, seventh power, you'll have a graph that looks similar to this. But this graph specifically right here is the cubic graph, which you'll see you'll use the cubic function more commonly. But the cubic function is a polynomial odd function, okay? But if you were to call x to the fifth power a cubic function, that would be wrong. Same thing back here. If you were to do like x to the fourth power and you said, oh, it's a quadratic function, that would be wrong. So quadratic function is a term reserved just for x squared. Same thing for cubic function, reserved just for x to the third. But if you call x squared a polynomial even or x to the third polynomial odd, that's still correct. Okay, because it falls under that category. So hopefully that answers any questions you might have had as I explain this. But this one, left and right forever, up and down forever, no restrictions at all. That's because you're cubing something, or you just have an odd number of negatives. So 2 negatives or an even number of negatives would cancel out and make a positive, but an odd number, you just get right back to a negative. So that's why you can output positive and negative numbers on that. Okay, let's go on to the next page. Okay, so this graph right here is my square root function, okay? And you can only get positive numbers on the x. You can only input positive numbers, and so therefore you can only output positive numbers. So yeah, it touches 0, but you get no negative values on the x. You get no negative values on the y either. And that's because you can't take the square root of a negative number. So I can only plug in positive numbers into the square root function. All right? Because there's no inverse to it. You know, squaring something is a negative times a negative equals a positive number. Like negative 3 times negative 3 is 9. Same thing as 3 times 3 is 9. So if I were to take the square root of 9, I'd get 3 or negative 3. But if I were to do the square root of negative 9, I can't multiply 2 of the same number to get to negative 3. I'd have to do 3 and negative 3, and that's not the definition of a square root. Square root is it has to be that same number. So hopefully that makes sense as to why the square root function looks like that and why the domain and range are greater than or equal to 0, because you can take the square root of 0. And then I know I haven't mentioned it. Make sure you're writing x for the inequality notation on the domain and writing y for the inequality notation on the range. It's an easy mistake to make. A lot of times people will just write x's no matter what because you write x's a lot in algebra. I also did say that this is the polynomial square root or even root function, because if you did, the square root is like root 2, all right? So if you did like root 4, root 6, root 8, you'd have a similar looking graph. They all look slightly different, but it is similar looking. So again, it's the same reason as before with the polynomial even and polynomial odd. It's going to look similar, so that's why I added it on there. So the next one, this is your cubic root graph, or the odd root. If you did like the 5th root, 7th root, same thing. Similar looking graph, same domain and range as well. But as you can see, you can take the cube root of a negative number because, as I mentioned on the last page, you know, you can multiply an odd number of negative numbers and output an odd number. So therefore, there is an inverse of that. The cube root of negative 125 is negative 5, because negative 5 times negative 5 times negative 5 is negative 125. So that's why this one looks different than that one. This one right here is your inverse function. Okay, so the inverse function cannot touch the y-axis and it cannot touch the x-axis in its most basic form, and that's when f of x equals 1 divided by x. That's because you are dividing by x, and you can never divide by 0. So if I can't divide by 0, you can plug in any value less than 0 or any value greater than 0, but you can never specifically plug in 0. You wouldn't have to write this part right there, but I think it's good to know. I think it's good to write down. I just wrote it down here in the middle because this tells me that x can't equal 0, just this part up here. And then in interval notation, you have to use the union, because union means or. So negative infinity to 0, and then starts again at 0 and goes to positive infinity. So that tells me, since there's no brackets, it's never going to equal 0. But since you can't plug in the number 0, you'll also never output the number 0. You can divide the smallest number you can think of, as long as that number is just a little bit bigger than 0, which it will be since you can't divide by 0, you won't output the number 0. So you'll get very, very, very close, but you'll never equal 0. So that's why the domain and range have the same thing, and that's why you have a split going down here and going down there. You have an asymptote at the x-axis and the y-axis. Now for your exponential function, e to the power of x, x is your exponent for exponential functions. You have a similar kind of deal where this is what I was talking about. It can never touch the x-axis because it's starting to curve, and then it's just going to skirt along that line. That's because if you were to do a really, really small exponent, you'd get a really, really small number, but you wouldn't get 0, okay? If you plug in 0 for your exponent, guess what? You get the number 1, all right? So that's why you're never going to equal 0 for the exponential function on this end. And then it just gets, really big numbers on this end. So it does move left and right forever, so all real numbers on the domain. And then the range, y is strictly greater than 0. It'll never equal 0. And then, interval notation 0 to infinity. The last thing to go over is the logarithmic function. So the basic logarithmic function is ln x. That's the natural log of x. So ln stands for natural log. But otherwise, if you're not using the natural log, you're just using log, you'll write the word log, and you do log of x. But both of these will get you a function that looks like this. And so you can see the domain here is restricted. It's never going to go on this negative side of the x. And it's never going to hit the y-axis. And the y-axis is when x equals 0. So x cannot equal 0. So x is strictly greater than 0. Okay? Or it goes from 0 to infinity, both in parentheses. But the range, it goes down forever, it goes up forever. So the range is all real numbers. So there, that finishes my little overview of all the functions you see in Algebra 2 with the domains and ranges. But yeah, goodbye everybody.